And I think we're good with that. So I'm imagining people will kind of pop in. I'll try to keep my chat open, but it gets a lot. So if you try chatting and I don't respond, maybe just like yell at me with the audio and I will try to be on top of it. Multitasking with multi-windows and Zoom with screen sharing is it's even more fun than the real thing. Okay, so today we're going to talk about 2D arrays. Of course, we have to start with the funny thing, you know. Oh no, he's not null terminated. Anyways. So here's the plan. We're going to look at 2D arrays, which are, you can kind of think of as arrays of arrays. One array is a bunch of rows, and then each row is an array of values. So in some ways, this does definitely get a bit trickier than what we've seen already with 1D arrays. So we'll do a bunch. Basically, we're gonna look at some syntax and sort of what's going on under the hood, and then we're just going to do a whole bunch of examples. And next week in lab, I'll give you a chance to practice with this in lab. Okay, so like I was saying, we can kind of think of arrays as like arrays of arrays, but you can also think of them as like a table where we have, just like we did before, we have 0 indexing. So here we have 6 rows, sorry, and 5 columns. So the rows will go from indices 0 to 5, and the columns will go from indices 0 to 4. So row 0 of our array, which is our first row, would have the values 1, 1, 1, 1, 1 in it. You can sort of see what's going on here. And then similarly, column 1 or the second column would have these values in it. And we'll look at what this looks like in terms of actually accessing the values. We can also access a single element in an array by using the row and then the column in square bracket notation. So same square brackets that we saw when we were accessing 1D arrays, but we have to specify both the row and the column. And so this would return the value 1 that's at row 0, column 1. So some of the sort of like under the hood nitty gritty stuff about 2D arrays. So just like we saw with our C and C++ arrays, 1D arrays, all the data within our 2D array has to be of the same type. We have to specify the size of our array currently until we get to pointers, terrifyingly next week, probably. At compile time. So that means we need to use a constant or a literal to specify both the number of rows and the number of columns. So to declare a 2D array, the general syntax is first, we specify the type, then we give it an identifier or a name, and then we specify the number of rows and then the number of columns in square bracket notation, followed by a semicolon, which I omitted in the syntax piece. So here we can see an example where we've declared an array of doubles named numbers with 5 rows and 10 columns. So just pipe in if you have any questions or if anything's unclear. Just like we did with 1D arrays, when we want to access an element of an array, with a 2D array, we use the square bracket notation, except now we have to have one set of square brackets for the row and one set of square brackets for the column. And then we can do things, we can set values or we can get values using this notation. So if we wanted to retrieve the value at index 0, 2, so row 0, column 2, and assign it to a variable, we could do that like we do here, double x equals numbers 0, 2. We can also, even though we have to use constants or literals to declare the size of our array, when we actually create the array, we can use variables to access elements of an array, which is good because otherwise how would we use like for loops to iterate through arrays and stuff, right? So we just have to be careful. We don't really have any safety checks here like you do in some languages to find out how big our array is automatically. So we have to make sure that whatever value we use is within the bounds of the array. So if we go back to our array here, we are actually doing bad things. If we originally declared it with 5 rows and 10 columns, this here where we set y to I just lost my mind for a second, to 10, we're exceeding the bounds of the array. Okay. It's interesting. So, sorry, I got distracted there for a second by what was going on. So here we're going to look at a bigger example where we're going to write some code to fill this array with some values. And here we're using like I to the j. And then get values in specific areas. So I'm going to open up a demo code. Can you guys see my C++ file? Awesome. I like when things actually work the way you like anticipated. Okay, and I'll bring my compiler up as well. Okay, so I'm going to be like typing over my shoulder because it's over on the size. So what we're going to do here is we can see the declaration code that's on the, I can see it anyways. There, now you can see it, that's on the slide. So we're going to do that. So we're going to declare some constants up above here for our size of our array. So int rows equals 11, const int calls equals 6. And then in our main, we're going to declare this array. So we're going to call it powers, and we're going to make it rows by calls, except with the right kind of brackets. So that's us declaring the actual array itself. And now we want to fill this with values. And you can see that I've included CMath in this file. And we're going to use a for loop. And because we have 2D array, we're going to use a for loop within a for loop. So this is sometimes the part that's a little tricky. So we're going to for int I equals 0. I can find the 0. There we go. I less than rows. So the outer loop is going to iterate over each row of our array. The inner loop, we have to use a different index. So we're going to use j equals 0, j less than calls, j plus plus. So when we iterate through this loop, we're going to go through one row at a time and then each column within that row. And we're going to set the value of our element by accessing index I, index j equals, and we could set it to whatever we wanted to here. So let's just start for now by just setting it all to, I don't know, we'll set it all to 1. And then we'll write the code to output it. And then because I'm lazy, I'm going to use the same nested for loops to output our code. And this just gives me a way to test it before we add the complexity of like actually putting the I to the power j inside the array. So in here, we're using CSTDIO. So we'll printf, and then these are doubles. So we want %f. Oh, I think LF because they're long floats. And then I'm going to put a space. And this is the bit that's a little tricky. And then our value. So now we're going to say powers I, j. So this is going to happen. The inside loop is going to iterate over all columns. And after each row, I want to put a new line so that it'll print out kind of nicely. So I'm going to put the new line outside the inner for loop. So we're going to put spaces between each of the values and then a new line at the end of each row for each of them. So let's try compiling that now. What am I call this? Demos. It's going to be slow. Come on. Well, that's promising. Demos X. So we get our 10 rows or 11 rows, sorry, by 6 column array output. And we could, if we wanted to like do like 0.2 and try that again. So it's a little smaller. It's not going to take up as much space. Okay, so we can see now how we can write values into our elements and how we can get the values out using those square bracket notation. Let's do the magic-y bits here and let's call pow with I, J. And no, yes, that's what we wanted. So we're going to compute I to the power j and then see how that works. So that's what we're going to fill our array with. So we get all those values. So unsurprisingly, everything to the power 0 is 1. And 0 to the first row is a little interesting. 0 to the power 0. Not exactly sure. Anybody know what's going on there? Why am I getting 1 for the first one and zeros for the next? 0 to the 0. Oh, I guess 0 to the -1. Yeah, that to the 1. That makes sense. Okay, never mind. It does make sense. Bad computation. Excellent. I like when we have bad computation. Okay. So then, now that we can do that and we can output the sort of contents array, if we want to make this format a little nicer, we could put a tab here if I do this properly. And it's a little nicer, so they're kind of at least lined up on the left, a little bit nicer. We could do things with widths and stuff like that, but we're not going to. Okay, so let's also like see, he said, throw out your calculator if it does that. Perfect. So we're just going to throw out C++. I like that. Excellent. Okay, so what is our, it's probably documented in the code somewhere that you get bad things. Let's grab the value. Let's grab the last element in our array. So let's think about what that is. So if I want to printf the last element, and we know it's going to be a percent, we're going to do 0.2 again, LF. How do we access the last element in our 2D array with 11 rows and 6 columns? So we know we want to index into powers. And we know we want to see the number of rows minus 1 row, and same thing with calls minus 1, so that we don't go past the end of our array. So let's try that. And so that lines up with what we see in the table with our one badly columnized value because the values are too big. What about the first one? Is kind of an easy one, right? The first is just going to be at index 0. and 0. And then let's do one more. So sort of like, I don't know, the middle-ish element. So why don't we say like rows divided by 2 and calls divided by 2, because we can do math in there if we want to. And we compile that. So the middle-ish element is 1, 2, 5, which kind of makes sense. It's like right there in the middle-ish. So we're doing integer division, so it won't allow us to try to index into location 2.5, which would be, or whatever. Yeah, that would be bad. 6, 3. The 11 will divide into 6 point, whatever, 5.5. So we'll, but we do integer division, so we're all good. Okay. And then you can see on I can see on my slide that the other thing that we can do is we can do things like get all the values that are on even rows in column 4. Holy camole, that's a brain one. Or get all the values that are on the diagonal. So how would we get all the values that are on the diagonal? That's a good one. So we know we want to probably use loops. So we can grab our for loops. And now let's think about, let's not put this new, we want a new line at the end. So what do we want to do here if we want only on the diagonal? So what do the diagonal values have in common? Up to a point, we can only go so far, right? So our diagonal values are the ones here at 0, 0, 1, 1, 2, 2. So we can see 3, 3, 4, 4, and 5, 5. So we only want to print out the ones where the index, where index is the same in the row and the column, which we can check with an if. And here, what we want to see is if I equals j, then we want to printf. So we're still iterating through the whole array, the whole 2D array, but we're only going to output where they match. Oh, it decided to double close my thing. So that will be the diagonals. And let's put a little printf. Let's do this and a new line. Couldn't we use one loop? Yes, we totally could. Thank you, Craig, for being far more efficient. That is a smarter way. Here we'll do the diagonals the dumb way. I can just claim my excuse is that I'm under the weather and I equals 0, I less than calls. Because calls is smaller than rows. So we don't want to go past the end of our columns. And then we can do our printf again, except we just want to use I for both column and row and column, printf, put a new line. And then here we'll printf the Craig way. I really like the official way that you said that too, Craig. One loop, not the logic-y stuff. Ugh. All right. So, I mean, I did it different because I had new lines after each thing, but we're getting the same values, right? 1, 1, 4, 27, 256, 31, 25. Excellent. Okay, my last one was all even rows in column 4. So if we think about that, we need to go through each row, or at least every other row, for only one column. Oh, so we really only need one. Oh, this is a trick. We could do this the dumb way, but we'll do this the smart way. So we're going to do it for all of column 4 for every even row. So we do need to iterate over all. I'm going to put a comment in here what I'm doing. All even rows in column 4. So that's what we're trying to do. So we want to go from I equals 0. 0 is even. Not past rows. We want column 4, so we can actually just hard code our column value. Now this will output every row. And if we want just the even rows, how can we do that? We can go logic-y or we can do lazy. I'm going to do lazy. I equals I plus 2. Yeah, or plus equals 2 is the extra lazy. All right, let's try that. Oh, and I guess I should put a little, well, we'll see what it is. So I didn't put a new line at the end, which is why we're seeing the percent there output. And if we make our window a little bigger where you can see the whole table. So our column 4 should be this column here. So we're seeing 0. Interesting. 0, 1, 2, 3, 4. Are we seeing enough values? We're not seeing enough value. Oh yeah, we are, because we're seeing alternating. So 0, 16, 256, 1296, 4896, and our 10,000. Amazing. Okay, so there's our first sort of samples, creating 2D arrays, printing out 2D arrays, accessing specific elements in the arrays, accessing a specific column, specific values in rows. Okay, does anybody have any questions about that so far? You can put them in the chat. You can yell them at me. Okay, so I'm going to move on. If something comes up, if you're a slow typer, don't worry about it. You can just keep typing and I will see it. So let us, I'm going to close, hide this and hide this. So now we're going to talk about, we were just doing this all in the main, and we will want to do things where we write functions to work with 2D arrays. So just like our 1D arrays, 2D arrays are passed by reference. So by default, when we pass them into a function, we can modify them. There is a little bit of a weirdness with the syntax of that's different from how we did things with 1D arrays. When we pass a 1D array into a function, we would just say the type and then the identifier and then square brackets, empty. But when we want to pass a 2D array in, we have to specify the number of columns as a constant in the function declaration and the function definition. And we'll look at examples of what that actually means, because that is a little bit weird. I had a, I'm going to jump ahead to a slide that's later so you can kind of see what this looks like. And we'll come back to the slide in a minute. So you can see here that, and I haven't included the declaration of the function in here just for visibility's sake. So when I declare a function that's going to print out a table, I'm calling it a table, but it's just a 2D array with rows, and columns. I still use the empty square brackets for the number of rows. You can put the number of rows in there. The compiler won't complain, but I have to specify the number of columns right here. So these are for statically allocated arrays, arrays that the size is known at compile time. This is the syntax. And because, I mean, in this case, because we obviously know how many columns exist, you can also just pass in the number of rows here. And so then we have it. Now, we obviously, well, here we can't, because this is actually syntactically weird, because I've got calls declared in the main, but then I'm trying to access it here and that won't work. So these constants have to be declared up above. That's just silly. Okay, so let's do some, not those examples. I don't know why. I did something weird with my slides. I moved them around and now they don't make any sense, the order that they're in. I think we're probably okay with this idea of just declaring arrays. But this is actually kind of interesting. So just like we could with arrays, 1D arrays, we can actually specify the size of an array at declaration by using an initializer list. Now, what's a little bit weird about this with 2D arrays is we can do that two ways. We can do it by specifying the second one, which kind of makes sense here. This is one row and this is a second row, and each row has 4 values in it. But we can also do this, which is just a little weird. So we can just specify all the values one after another. I would recommend avoiding doing this first choice here, because this is much more clear that what you're doing is you're creating an array with 2 rows, each with 4 values. If you use the first one here, it's a lot harder to keep track of how many values are in each row and how many rows there are, and so on and so forth. But really what matters here is under the hood, we have a matrix of n by m elements. And so if the size of our array, of course, is determined by the number of rows and the number of columns. And what this probably hints at is how those values are put into memory. So it doesn't matter if we specify them all as one long initializer list or a series of row initializer lists. Oops, I'm gonna just randomly change slides there without even meaning to. That's awesome. Okay. So let's do this with we'll play with some examples here just to see what this looks like. So we're going to use our same demo. Maybe what I'll do is, I don't want to do initializer lists of 11 and 6. That doesn't sound fun. So let's change this. Let's make this 3 and 5 or something. And I'm going to comment out. Actually, I'm going to comment out all of this for now. And then here, let's fill this with, let's start the not dumb way. So let's create this with initializer lists, one for each row. And I'm just going to put integer values in here, 3. So I have 3 rows of 5 columns. So that's our first row. I'm going to do them on separate lines. So another open curly bracket. So then we'll do, I don't know, 10, 20, 30, 40, 50, just so that we can kind of see the difference. And then my next one will be 100, 200, 300, 400, and 500. And then I'm going to steal this and put it there. So this should work. Maybe it will work. We'll see. That's what I want. So let's compile. That's somewhat promising. And so there we have declared our array using an initializer list that is a set of rows passed in as, so 3 rows of 5 values. And then we can try the cheater way, and we can see that output kind of the way we expect it. So this is sort of, if you're going to do this, this is probably the way you want to do it. so that you actually get the right number of columns, the right number of rows. Let's try it this way and see what happens. Oh, yeah, so the compiler's being nice and telling us that maybe we're being dumb, but that's okay. We can be dumb and we get the exact same output. So I like that the compiler tells us that maybe suggest braces around initialization of sub-object. That is good advice, compiler. Thank you very much. Okay, so now we're going to kind of skip around again. Let's see if I can bring this to the front. There we go. So we're going to go back to the idea of passing arrays to functions, 2D arrays. So there's a couple different ways that we can do this. And we're going to look at both of these, and these are in the chess.cpp demo code. I think that's the one we want to do first. Let me just take a quick peek. Got a couple. There's this one, and there's also another one that's, I have too many folders open. There we go. Okay, so we're going to start with this one. So this is the chess one. I'm just going to continue using this file just because it's easier. And so a chessboard. So if we look back to our slides here, just give me a second. So we can use a type def to name the array with types to help out the compiler, but we're going to start with doing this the way that we've seen this so far, where we don't use a type def yet, and then we will add a type def to make it a little bit more straightforward. So if we were to do this without a type def, when we wanted to create our chessboard, they're just going to be integers. So we're actually treating them as character arrays. So let's do it as, sorry. So we're going to char chessboard, and then we're going to do rows, and these are the same values. So it's kind of silly to have different things for them, but that's okay. We're going to do that anyways. And then we could do things like write a function or use a for loop to fill in this thing. And in this case, it would work exactly like what we've seen before, where we could for int I equals 0, I less than rows, I plus plus. Let's put extra pluses at the end because that makes perfect sense. And then, because I'm lazy, do an inside one for J. Another thing that can be nice when you're working with arrays like this, 2D arrays. Oh, and I need to curly brace. Is to help you kind of think about which are the rows and which are the columns. Instead of using instead of using I and J, we can use R and C. So then sort of logically, when you're looking at your code, you can see that when you're indexing, that you're indexing into the row versus the column. And then we could do things like in here, if we wanted to access the chessboard at a certain row and a certain column, we could do that, just like we did before. So chessboard R C equals, and then some value. So if we just want to initialize these all to spaces to start, we could do that like this, except I need to capitalize. There we go. And you can see that, at least as far as my text editor is concerned, this seems to be correct. And if we we can at least test and make sure that that compiles. So that's what we've seen so far in terms of declaring an array. Here it's a char array instead of an int or a float. What we're going to look at, though, is how to use type defs to make this a little bit easier and make it a little easier to read into it. And here it's going to seem a little simple right here, but when we start using functions, it will make a lot more sense. So let's create a type def up here, and it's going to be of type char, and we're going to call it chess. If I can spell board. You'll see that I give it a capital at the beginning to indicate that it's like a user-defined type. And what this allows us to do is here, now that we have this chessboard, so instead of doing this, which we still can, we can say chessboard board. And this board now is a 2D array of characters with 8 rows and 8 columns. Why is there an right here? Why is there a space in line 21? Oh, because I'm just filling the array with spaces. So this initially here is me just creating a 8x8 array where each element in the array contains just a space. I could have put we could put like a star in here too, right? And then if I wanted to print this out, I could print it out and then we could actually see what I've done. We're not gonna leave it as a star. We're going to, let's print this out. So we'll say printf. And this is going to be a character now. So this is %C. And let's put a space between each one. No, let's not put a space. Yes, let's put a space. And then again, like we did before, we'll printf a new line after each row. What does it not? Oh, I have to actually say what the thing is. So board R C. So we'll compile and run, and we should just get a grid of stars. Okay, so an 8x8 grid of stars. But we want this to be a chessboard, and a chessboard does not have only, if we use the stars to represent the black square. If we want to have a white square, we want to have not a star, but we still want something, so we can put a space. So let's figure out the logic here. We want to put, and this is the fun bit, so we want to fill this with the first row. Now, I'm probably going to get chessboards wrong. I don't know which way they start, but we want the first row to be space, star, and then the second row to be star, space. So we're going to use our logic to check whether or not this cell should have a space or a star. And it's actually kind of tricky when you think about it. And what we're going to do is we're going to mod the sum of the row and the column. So what that ends up doing is if one of them is odd and one of them is even, we mod to them when they're added together, we'll get a 1. If they're both odd or they're both even, when we mod to them added together, we'll get a 0. So it'll help us very easily in a way. So we want to make this a, I don't remember what I was going to comment there. Here, like a comment. There we go. That's my comment. So here we're going to say if, and I'm going to just bracket this like crazy. So if R plus C mod 2, ow, my cat is poking me in the leg, equals 0, else. So in one case, we want to do this. And in the other case, and you're welcome to be, if you know the way chessboards really work and you want to be pedantic and tell me that I did it backwards, I'm more than happy to hear that. Because it's easy to fix right now. This is like we're doing magic. Da, 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 da. Is that amazing or what? We like alternated odd even rows to make a chessboard in so few lines. Are we impressed with ourselves or what? I'm impressed, but maybe I'm easily impressed. Okay. So let us, let's see, what does my next slide say? So that's our chess. Now we're going to do something, we're going to write functions. The top left and bottom are the light color. Phew. Okay, so we're not like in backwards land of chessboards. That's reassuring. Okay, so now we're gonna do another demo, and so now we're gonna actually write functions, and so we're gonna see both of the situations where we use a type def versus not use a type def, and we'll see how the how that impacts things. So I want this one here. I have so many files open right now, it's ridiculous. So we're going to write our code in here. And we're going to do the first one. I'm going to sneeze in a second. Maybe. Definitely. Okay. Oh, I hate that feeling of like having to sneeze. Okay, so what are we going to do? Let us start with, we'll start with the easy one, which is the multiplication table for 12 by 12. So we're going to write a function to output it using a type def. So we're going to create the array, fill it with the multiplication table, and then output it. And we're going to use a function to do that output. And that function is going to use a type def. So so these are our values right here that we're going to use for the number of rows and columns for our multiplication table. And let's create a type def for our array. So int table. So we're just going to call it table. It's a multiplication table, and it's going to be rows by calls. And then in our main, oh, I don't know why I did that. That just makes me crazy sometimes. Okay, in our main, we're going to declare a table that's going to be a multiplication table. So we're going to call it table mult table, so we know what it is. So this is now a 2D array of integers that's 12 by 12. And we're just going to fill it inside our main. For int I equals, no, we're going to do r equals 0, r less than rows, r plus plus. And then I'm lazy, so I'm going to copy this. C less than calls, and C plus plus. And then our braces. Okay, so in here, since we're filling it with the multiplication table, it's not too tricky to figure out what to put in each value, but we're going to go into index R, into index C is going to be equal to. Now we could do a multiplication table computer science style and have the 0 rows, but they're kind of boring. So we're going to add 1 to the rows times the 1 to the columns. So we actually have the 1 row, the 2 row, the 3 row, the 4 row, up to 12. So this will be from 1 to 12. Now we want to output it, but we're going to use a function to do that. The function doesn't need to return anything, so we can make it void. We're going to call it output table. And this is where the type def part is kind of cool. So here, all we have to say is table T. Remember before I said you had to specify the number of columns when you declare a function that takes a 2D array as a parameter. Well, because we're using a type def, and the type def is known at compile time, the compiler knows how many columns are in there. So we don't actually explicitly have to put it in there. So it makes our life a little easier. Okay, so now we can output it. And we're going to say I'm going to use I and J because it types faster in my brain. I less than rows, I plus plus. For int J equals 0, J less than calls. Nope, J plus plus. And then here we're using CSCI still, so we're going to printf. And these are integers, so %d and a space, and then t at index I at index j. So I named my local 2D array t, and then a new line. I can do it. There we go. Okay, so let's try compiling that. Sorry. See how it likes it. Oh, I should try calling my function too, shouldn't I? Yeah, that would make sense. So let's call output table. And this is important, this little bit here. So when we pass in a 2D array, just like before, I mean, here it's a little bit confusing because we have a type def, but you don't have to, you just pass in the identifier. So we don't have to specify any square brackets when we call a function with an array. So let's try that again. So we have some constants that aren't being used, but that's okay. We expect that. So there is our array. Let's make this prettier. Let's use a tab in here instead of a space. Oh, look at that. It's so pretty. So that's our 12 by 12 multiplication table in case you need to do that. You know, and if you're in elementary school and you need to, somebody yells out 8 times 7. I still have nightmares about that. Okay, so that's what it looks like if we have a type def for our 2D array and we want to create an array and then call a function. So the next thing that we're going to do is we're going to do this once more with feeling, but we're going to do a slightly different example. So if we look at our thing, so declare an array to hold 10 lab grades and their average for up to 100 students. And then we're going to write a function that will initialize that to 0 without a type def, and then write a function to output it without a type def. Okay, so here are our, if we want the average in there, we need one more. I don't know what I was thinking. Okay, so we're going to put this, do this before our multiplication table. No, we'll do it after our multiplication table stuff. And maybe we'll not output this just for clarity. Okay, so we want an array of grades. These are going to be floating point values, and we're not going to use a type def. So we're just going to, say float, and we're going to call it grades list. And it's going to be, we're going to have the 1 row per grade, 1 column per student. So num tut, that's my tutorial, the number of tutorials, that's how many rows there are. And then num stu for the number of columns. And then let's, we're going to fill it initially with zeros, and we're going to create a function to do that. So we're going to call this init grades, and it's going to take as parameter an array of floats. We're just going to call it list here to differentiate it from the one that we've declared in our main. So this is what it's going to be called inside the array, inside the function. So for the number of rows, we can still leave it a blank, empty, open, close square bracket. But for the number of columns, we need to specify it. So here is our function declaration, and now we're going to define it down here. Now, it's not going to be, there's going to be a lot of repetition here. So, we're going to iterate through. So for int I, really what we are caring about here is seeing what declaring, defining, and calling the function looks like with a 2D array. So 0, I less than, and so here we have num tutorial I++. And then for int j equals 0, j less than num stu j++. How many times will you put I in that inner for loop and then be confused about why it doesn't work? Approximately 1 bajillion. Okay, so in here, we're just going to initialize our whole array to 0. So for list at index I, at index j equals 0. So that will initialize it. And then we're going to create another function that will print it out. And I'm lazy, so I'm going to just copy this. And I'm going to call it print grades. And then similarly, because I'm lazy, I'm going to copy this. Because I know I need to use the same for loop. So here, I'm going to printf, and these are floating point values. So, and we'll do like 0.2 or something, or 0.1 f. And then we'll do a tab again so that they look nice. And then we're going to index into list at index I at index j. And then a new line after each row. So here we've declared our array. Now we're going to call our init grades function. And we're going to pass in our grades list. All we have to say is grades. I did lowercase l there, didn't I? That's terrible. No, that's bad, Sarah. Let's fix that. There we go. So that will fill it with zeros. And then we want to output it. So print grades, and we're going to pass in grades list with a capital L. Oh, and a semicolon. Okay, so let's see if I broke it. I didn't, maybe. Holy, that's a lot because we have 100 across. Whew. Can we even see how many? No, we can't. It might have been dumb to do it this way, but that's just how we did it. So that's that's how I did it. Okay. Let's do one last thing in here. Let's compute. Right now we have 0 in the last element, and you can see I've got 11. Let's do 10. I'm going to compute the average for each student and just output it. Let's do that in the main. So each student has its own column. We're doing this the hard way. Whew. We want to do this for each column, compute the average. We have to sum for each column, sum all the row values, and then take the average. How do we do that? Who's got a brainy idea about how to do that? Anyone? We want to use for loops, but I want to like iterate through the columns. Do this once for each column. So for each column, sum the values, there are 10 of them, then divide by 10. So I know I want to iterate. I want a for loop, and I do need to do this for every column, for every row. The trick is, because I put the students in columns, the way that we've been looping over each row and then across each column. And we want to loop over each column and then across down each column. Oh, how do we do that? So we can still use the same sort of idea. We're just going to kind of do it backwards. I mean, we don't have like meaningful values in here. So let's we're going to do something. We're going to fill it with random values in a second. But let's think about how to do this. So I++. So we do want to iterate over each column. We might break Sarah's brain today. So we're going to use C here because otherwise I will get really confused. And then int r equals 0, r less than num tutorial, r++. R, I can do it. There we go. R++. Sorry, I got my things all weird. Okay. The part that's backwards here is, so we want to sum. So we're going to do int sum right here, and we're going to set it to 0 initially. And then I'm going to say sum equals, now this is the part, so it's plus equals because we're going to add onto it what the next value is. But this is the part that's going to be like, I mean, it's going to look normal. It's not going to look weird, but it is going to be weird. So we want, this is our grades list at index R C. I can type, I swear. But you notice that we're iterating over the columns first and then over the rows, which is a tricky little trick. And then after each column, we want to say print this average. Let's do student percent D. When you get a chance after class, can you say to our team 3? Oh, yeah. Totally. Didn't realize he wasn't in it. That's weird. And then we're going to percent 0.1F. And we're going to put a new line. So I'm going to put for my first value, I'm going to put the C+1. So that's going to be the student's column index +1, just so we don't start indexing at 0. And then the sum divided by 10.10. Sorry, just 10. Because it is sum is already a float, so we will get floating point division. In theory, that should work. Now we're going to get, why is it complaining? Double, but the argument has type int. Apparently, oh, because I did that. That's silly. I was silly. Okay. So let's try this. We're going to get 0 for each one of them, which that's probably a good thing, but we should get 100 answers. That's our first test. For student 1 to 100. So we correctly computed the average of 10 zeros. We're amazing. Okay, let's do something fun here. So instead of doing this, so let's see here. Sorry, I'm just pulling up other things. So let us here, let's call srand with time null. What do I need to include? Time is in brain. I can't remember what time is in. I've lost my mind. Will it tell me? No. Who's going to tell me? Oh, thank you. That's the one. Brain. Okay, so we're gonna seed our random number generator. And when we initialize here, instead of initializing to 0, we want values between 0 to 100. So we're going to say rand mod 101. That will let us get up from 0 to 100. That is correct, I think. Let's see what we got. I'm firing on like 2 brain cells. So our table looks okay-ish. They look like they have values from 0 to 100. There's a 0, that's promising. Are there any 100s? Oh, there's a 100. Are there any that are bigger than 100? No. And then there's all of our averages. One for each student. There you go. Okay, so that is that. So now we've seen the difference. What is the average of the average? Oh, Craig, we need another variable. Float totes average equals. There we go. Tote average plus equals sum. And then we don't need this bit. We do need this bit. We need to divide it by 100 because there were 100 students. Totes average. It's a good name, eh? Always name your variables well. That doesn't make sense. Does it? How does the average end up being big? Okay, the value is reset. Who sees my mistake? That's our class average. Your class average is 496.6%? That's amazing. Seriously, what did I do wrong? I'm very confused. I initialized tote average to 0. I sum on, oh, I have to divide this by 10. That's why. I have to add the averages. That's why. I can guess what it's going to be. 47. That's not so good. I think our random number generator is not so great. Oh, I guess it's around 50. You kind of would expect it to be around 50, right? Okay. Just seemed a little low that first time. If it's randomly, I mean, I'm not sure. Yeah, we're getting a fairly even distribution of values between 0 and 100. Then we should start seeing that get close to 50. Look at that. We got 50 right there. I stopped it at the perfect time. Okay. Is everybody's brain full? We all have 500%. I mean, that would be awesome if we could all get 500%, but I think maybe the math students might not appreciate that. It doesn't make sense. Okay, I'm going to stop there because I think probably our brains are full. I'm eating cake for breakfast. Connor is living the good life. I'm drinking cold coffee for breakfast. There you go. Because I made my coffee at 6 in the morning and then I'm still drinking it because that's how I roll. Okay, so we will on Thursday continue. I will answer your question in a second, Craig. Yes. We will continue with more 2D array examples on Thursday and a quiz to practice some stuff. Yes, I would like to say we have lab today. I will not physically be there though, because I'm a coughing, sneezing mess. And I would like to not cough and sneeze all over everybody. So the plan for lab is I propose that people attend lab in a way that works for their team, because you're going to continue working on your team lab that you started last week and is due this Friday. And I think it's up to teams how they want to do that. It might be easier if you're on campus to work in lab to do that. Or you could try remote access. That gets a little trickier. I will be on Discord. So I think most teams got fairly close to done. I'm saying Discord because it's a little easier, I think, for me to multitask with more than one team in Discord than it is in Zoom. Because I can hop into a voice channel in Discord with a team, but still see chats that everybody is posting. And we can stream code easier. Yeah, exactly. Like if we can screen share in Discord pretty easily. And you should be able to do that from the lab machines even. You can open Discord in a browser and do it that way. If that doesn't work, I can open up Zoom and have and then invite, I'll use this. I always use the same Zoom link and stuff. So I'll just be there in Discord from 4:30 to 6:30. And if we need to use Zoom, we can use Zoom. So if we go into our Discord, if I can go into my Discord, there are a bunch of voice channels. They're numbered. So there's there's 8 different Discord channels. So I'll just hop into one of the voice channels and everybody can hop in there. And then if teams want to, I'll hop in like voice channel 5, and then teams can use the separate voice channels themselves if they want to, or whatever. We can just kind of figure it out as we go along. Yeah. Does anybody have any other questions? I'm going to stop sharing. And I will, when I'm done with this, it'll take a minute for it to do its thing. But then I'll post this video up on VIU Learn. It might take a minute for me to upload it onto VIU YouTube. Is there an easy way to remote lab computer? The easiest way is to use SSH. You can try to use the help center. The help center this afternoon is canceled, so that's bad timing. And you have a doc. So yeah, Connor, do you want to share that document on SSH in the class Discord? There's also, and I'll put some links in there from Dave's got some how-tos and stuff like that. And I would just say check with your team and see what your team thinks in terms of the best way for you to collaborate together, because it can be a little tricky to communicate remotely when you're trying to write one file. So first check with your team and make sure that everybody's happy. Okay, I'm going to put that in the general in our class Discord. Thanks, Connor. Yeah, and I'll go to Dave's tech notes and I'll grab the link that's got information there as well. Add walk to team 3, please. Oh, because he came in late, and that's what it is, right? Yes, no roles. That's no good. Done. It's that quick and easy. Okay, so I will see you all at 4:30 online. Like I said, if anybody's having trouble connecting to the Discord or whatever, you can just fire me a quick message and I will open up Zoom and I'll hop on Zoom. I can do both at the same time because that's always fun. Yeah, awesome. And otherwise, hopefully I'll see you in person on Thursday too. I'm just going to kick this in the butt, but I'm going to come to class only after I've done that. Okay. Thank you, everyone. I'm going to turn off the recording.